In this video, I'm going to show the general process for using completing the square, as well as a couple specific applications like solving an equation or proving that what you're looking at is a specific conic shape, like a parabola, an ellipse, or a hyperbola. So first, let's look at the steps for the completing the square process itself. And like I said, there are different ways to perform more operations after you've completed the square because it sets things up in a specific way for us to make it easier to solve an equation, for example. But the actual act of completing the square is just a couple short steps. First, you need to get the equation in the form x squared plus bx equals c. The most important thing I want to highlight here is that there is no number in front of the x squared or whatever variable you have squared. You should not see like a 2x squared or a 5x squared. If you get a number in that spot, then you need to divide everything in the equation by that value, or you might just need to factor it out of the x terms. So factor it out front and then just do completing the square inside of the parentheses. Once you've done that, you're going to look at whatever your b value is, because the next step is to take b, divide it by 2, and then square it. So b is the middle number. It's the one attached to the variable to the first power. So if that middle number is a 4, for example, you would take 4, divide it by 2 to get 2, and then square it. That number, whatever you get from this process here, is added to both sides of the equation. Now you have to add it to both sides because the original equation is saying that the stuff on the left is the same value as the stuff on the right. So if you just randomly added a number to one side, it would no longer be balanced. That's why you have to do it on both sides of the equation so that your two different statements are still equal to each other. And then your last step is to factor the left side of the equation. Now, as a shortcut, what I'm telling you right here is that the trinomial you will have on the left-hand side of the equation can always be factored down to be x, or whatever variable you have, and half of the middle number. Not the middle number, not half of the middle number squared, just half of the middle number. So if your middle number was a 10, then I'm telling you that the factoring will be x plus 5 in parentheses, and then outside of the parentheses, squared. And then as a comment, like I said, after you complete the square, you are often going to solve an equation using your new setup, or you might use that to prove what you have is a specific conic shape. So if you are completing the square to solve an equation, I'll just briefly comment that you would continue doing your opposite operations from there. So your next step would be to take the square root of both sides of the equation. Don't forget to use the plus or minus answers, and then you would solve each of those separate answers separately. This is the most common use of completing the square, but I will be showing other applications as well. So here's an example where I'm not going to solve an equation, I'm not going to identify a conic shape or anything, I'm just going to show the process of completing the square. Now, the first requirement here is that I need to get everything into the appropriate form. So in this example, I'm going to start off by moving the constant to the opposite side of the equation. So opposite operations, the opposite of subtracting 20 is adding 20 to move that over. Next, you'll notice that in the standard form for setting and completing the square, I said that you cannot have a number in front of x squared. If you have a number there, you either need to factor it out, or if you can, just divide everything in your equation by that value. So in this case, I'm going to divide everything by a negative 2. So what I'll be left with is x squared minus 6x, and I'm going to leave a space for the next step, equals negative 10. Now that I've met the requirements to complete the square, this is the actual step of completing the square. You look at your b value, which is the number attached to the first power variable. So here's my x to the first power. The number attached to that is negative 6. If you take half of that number and square it, so the rule for this is b over 2 squared. In my example, I'm taking half of negative 6, which is negative 3, squared is 9. That number you get from b over 2 squared needs to be added to both sides of the equation. So your next step here is to factor down the left-hand side of the equation. You're looking for two numbers that multiply to 9 and add up to negative 6. But as a shortcut, I'll tell you that this is always going to factor down in a specific way. It's going to be whatever variable you have and half of the middle number. Not half of the middle number squared like we did here to get 9. It's just the half of the middle number before you square it. So in this case, -3. And if you factored it the old-fashioned way, you would see that the reason that works is because -3 times -3 is 9, and -3 minus 3 is -6. So this is just a shortcut to figure out the factoring. And on the other side of the equation, I can now combine these two numbers. -10 plus 9 is -1. So that right there is the process of completing the square. It's that step where you take half of the middle number, square it, and add it to both sides. It seems really random because you're just picking a number that has nothing to do with anything else you see, and you're just adding it to the left and the right-hand side. But the reason we do it is because it makes this left-hand side factor down very nicely. That's the entire point of completing the square. It's that it makes the left-hand side factor down to be a binomial squared. That's why it's called completing the square. We completed this trinomial so that it was a binomial squared. So completing the square comes from the fact that we're turning it into something squared. Now let's look at a quick application of completing the square. In this case, I'm going to use completing the square to solve an equation and figure out what x equals. Our first step is to get things into the appropriate form so that we can use completing the square. So for this problem, I need to move that -15 to the opposite side of the equation. So opposite operation, the opposite of subtracting is adding 15. Here's the completing the square. Right now, I wouldn't be able to factor this down to get a nice binomial squared. I need to add in another number to make it factor down nicely. So I'm going to take half of this middle number, which is 7, and then square that, which is 49. That is the number that I'm adding to both sides of my equation. So the reason we did that is because now if I find two numbers that multiply to 49 but that add up to 14, I'll find that those two numbers are both 7. 7 times 7 is 49. 7 plus 7 is 14. So we have completed the square to turn this piece into a binomial squared. And on the other side of the equation, I can combine 15 plus 49 to get 64. So that's it for the completing the square part. But in these directions, we were asked to solve the equation using completing the square. So the completing the square part is done. Now I'm just going to finish solving the equation from what's left. The opposite of a square is a square root. So if I took the square root of both sides of the equation, I would have x plus 7. And on the other side of the equation, don't forget the plus or minus. If you take the square root of both sides of an equation, you get a positive and negative answer, 8, because the square root of 64 is 8. Now I'm going to take my x plus 7 expression and set it equal to 8 and -8 separately. So I can write x plus 7 equals 8. Or I could write x plus 7 equals a -8. So if I solve these two equations for the first one, by subtracting 7 from both sides, I get x equals 1. And for this one, by subtracting 7 from both sides, I get x equals -15. So we found two answers for x based on our original equation. The alternative to using this completing the square technique would have been to use the quadratic formula, the -b plus or minus square root of b squared minus 4ac all over 2a. So this is an alternative application of completing the square that you can solve an equation with it, the same types of equations that you could solve with the quadratic formula. Now here's the last and the most complicated of the applications for completing the square. The reason it's more complicated is because we're actually going to have to do it twice within this one problem. So when you're dealing with something called a conic section, for an example, a hyperbola, the standard form can be created by using completing the square on the x's and the y's. So my first step here is going to be to group the x's and the y terms separately. So I'm going to leave a space for completing the square, and then I'm going to have a negative y squared plus 4y equals 6. So I added 6 to both sides of the equation. Now we need to look at our coefficients on the x squared and the y squared terms. For this first one, it's fine because I don't have a number in front of the x squared. It's just a 1. So I can leave that one as is. On the other side, for the y's, I do have a problem because I need to turn this into a y squared by itself. So I'm going to factor out that negative and make this y squared minus 4y. So I'm factoring out whatever number, whatever coefficient I have, so that it's just a y squared inside of my parentheses. Since I factored out a negative, I also had to factor the negative out of the 4y. That's why that sign changed as well. So both signs changed if you're looking at what's inside the parentheses. Now that I have an x squared by itself and a y squared by itself, I can do completing the square twice, once with the x's and once with the y's. So half of my middle number is negative 1. If I square that, that would be plus 1. And then for this next piece, half of the middle number is negative 2. Squared is plus 4. But here's the trick. Since I had to factor a number out of this trinomial, I'm not actually adding 4 to the left-hand side of the equation. If I distributed my negative back through, I would find that I was actually subtracting 4 from both sides of the equation. So whatever number you factor out, multiply that by what you got from completing the square inside the parentheses, and then put that same value on the opposite side. So in this case, negative 1 times 4 is negative 4 on the other side. That's how I'm keeping my equation balanced. The shortcut for factoring still works. So this trinomial will be x minus 1 squared, and this trinomial will be y minus 2 squared. And if I combine the like terms here, 6 plus 1 is 7, minus 4 is 3. So we just did completing the square twice, with the complication being that sometimes you have to factor a number out, and once you do, make sure you distribute it by the number that completes the square. Anything that you factored out, distribute it to what you completed the square with, and put it on the other side of the equation as well. Now there's one last step to finish off this hyperbola, this application. The standard form for a hyperbola should have equals to 1 here, so I'm going to divide by whatever number I see from everything in my equation. And if there's any simplifying to do within the fractions, make sure you reduce those fractions, whatever you have. But in this case, I'm just going to have x minus 1 squared over 3 minus y minus 2 squared over 3, and 3 divided by 3 is equal to 1. So now we have the standard form of our hyperbola, which we would be able to analyze and break down into smaller pieces regarding that lesson. So the completing the square was just the steps of taking half of the middle number, squaring it, and adding it to both sides of the equation. Just please, please, please be careful about all of the requirements we had about not having a number in front of your x squared. If you do, make sure you factor it out or divide it out of everything in your equation. So that's it for completing the square.